So, good afternoon, everyone, and welcome to this lecture. This is lecture number two, units and dimension. Am I audible and visible to all of you? Can you all see me? Online people, offline people, Anjali, Kartik, Shilata, everyone can see me and hear me? Am I audible and visible, beta? Please raise your hands and let me know. You can see me, you can hear me. Okay, so let us go and start today's class. In yesterday's class, we had seen what do you mean by dimensions, and we had started with the use of dimension. Yes or no? We had seen that the first use of dimension is to change physical quantity from one unit or one system to the other system. We had seen how to convert from kilometer per hour into meter per second, and then we had seen this. Formula of conversion. You can also use this formula where this formula says that n1 into u1 will be equal to n2 into u2, or n into u is a constant. Do we understand this? Do we remember this? Okay. Now let us see some example of this use. Any of these example can come as a question, and I hope that you can solve this. So let us solve an example. Okay. Do you know what is the SI unit of force? SI unit of force is known as, what is SI unit of force known as? SI unit of force, what is it known as? Do we know this? Online class, offline class? The SI unit of force is Newton, N, and the CGS unit of force is known as Dyne, DYNE. Now you must also know that how much is 1 Newton, or instead of writing it as Newton, I can write it as kg meter per second square. Do we know this? Yes or no? Please raise your hand so that I understand that you understand this. The SI unit of force is Newton, which can be written as kg meter per second square. Yes or no? Okay. Similarly, Dyne, which is the CGS unit of force, will be written as gram centimeter per second square. What we are asking here is convert 1 Newton into Dyne. How much is 1 Newton converted into Dynes? So I'll give you a minute to solve this one. Converting from the SI unit of force to the CGS unit of force. SI unit of force in yellow is known as Newton. The CGS unit of force in green is known as Dyne. You have to convert Newton into Dyne, and I'll give you a minute to do this. Are you able to do this, everyone? You got the answers? Or shall I help you out? If you got the answer, you can raise your hands and tell me what is the answer. Online students, 10 raised to the power 6. Karthik says 10 raised to the power 6. Karthik, I think it's probably, you have probably done a mistake in calculating. So please check the formula that you get or the answer that you get. 10 raised to the power 6 is some small mistake here. Anyone else got any answer? You got the answer, this is yes. You got the answer, this is no.
10
Yes?
to the power 5, sir.
10 to the power 5, that is correct. And how are you supposed to do it? Can you tell me? How did you do it, beta? So basically, you have to convert Newton N into Dyne, D-Y-N-E. Now you just write how much is Newton. 1 Newton is kg meter per second square. That has to be converted into gram
Gram centimeter per
centimeter
second
per
square.
second square. So what you got to do is convert kg into grams,
Meters to centimeters.
kg into grams. So how do you convert kg into grams?
It is 1000
You
grams.
multiply 1 kg, which will be equal to
1000
1000
grams.
grams. So this is how you have converted kg into grams. Then the next thing that you do, my dear friend, is to convert meters
Into
into
centimeters.
centimeter. How do you convert meter into centimeter?
1 meter 100 centimeters.
1 meter is 100 centimeters. So this is how it's converted from meter to centimeters. In the denominator, you have second square. Here also you have second
Second
square. So
square.
you don't have to convert second into seconds because that does not make any difference. So your final answer becomes, here it is Newton on this side, here it is Diane on this side. So I have 1 Newton is equal to 3
10
into
to the
2, 10
power
raised to the
5.
power 5. The answer is 1 Newton becomes 10 raised to the power 5 Dianes. That is the final answer that we get. Do we understand this? Yes or no? How we have done this? Anyone, can you just raise your hands in the chat as well as in the class so that I understand that we are able to do this? We are able to
Yes,
understand
sir.
this. Yes or no?
Yes, sir.
Okay. Now here also you can understand same principle that I was talking. This one is the numerical value n, or I call it n1. This Newton is the unit in the SI system. So n1 into u1. And if you look on the right hand side, what do you get? You get this one, which is
N2
n2. You get this
into
one,
U2.
which is u2. So basically you get n1 u1 is equal to n2
Into
u2. Do we
U2.
understand this?
Yes, sir.
Well, as you can see, it is pretty simple. This is how you convert. This is how you convert from one system to other. Can I give you another question?
Yes, sir.
Okay, well done. Let us move on to next question. Question number 2. Remember, question can be asked in different ways. This is question number 2. If the unit of or if I say if the new unit of meter, let me call this as meter dash. If the new unit of meter, which is meter dash, it 10 times the meter. So I create a new system in which my meter is 10 times of original meter. My new kg, which is kg dash, is equal to 100 times kg, and my new second dash, new second, is 1 by 10 times of the original second. Find new v dash. You understand the meaning of v dash? New velocity.
New velocity.
And new f dash. Do you understand meaning of f dash?
New.
New force. New SI
Yes.
unit of force. If the original values are v and f. So in the original system, which is our system, the values of velocity and force is v and f. I create a new system in which my meter becomes 10 times meter, my kg becomes 100 times kg, and my second becomes 1 by 10 times of seconds. What is the value of new v dash and new force in this new system? I'll give you a minute to do it. Okay, so I think you have done this. Karthik has given me answers as well. Well done, Karthik. The answers are there. Karthik says that the new velocity v dash is 100 times of v, and the new force f dash or f1 is 10 raised to the power 5 times f. Well done, Karthik. You got the answer. That means you have tried the question, and your answer also seems correct. Answer correct or not doesn't matter right now. What matters is that you are trying it or not. Shall I do it now? Everybody's ready? So let me call the original velocity as v. Original velocity v is meter per second. The new velocity v dash will be meter dash per second dash. Yes or no? Now instead of meter dash, I will put the value of meter dash. And as you can see, the yellow one, the value of meter dash, yellow one is nothing but, my dear friends, 10 times of meters. So I put 10 times of meter, yellow dash. Then I look at the new seconds, which is red, which is pink. New second is 1 by times of second, second dash. I will just substitute the value of second dash. Second dash is 1 by 10 times of second. 1 by 10 times of second. So what do I have here? It's 10 divided by 1 by 10. So I get 100 times. And I get this meter by second again. This blue quantity meter by second. This blue quantity meter by second. This blue quantity meter by second is nothing but your original velocity. So if I put all these things together, my new velocity becomes 100 times of the old velocity. Do we understand this?
Yes, sir.
So that is the answer to my first question. The new velocity v dash is 100 times the value of v. So as simple as that. I can repeat the same steps to find out the value of new force. If I write the value of original force, the original force will be kg meter per second square. The new value of force F dash will be kg kg dash meter dash per second dash squared. I just need to substitute the values, my dear friend. Kg in green is to be kg dash in green must be converted into kg. How am I going to do this? I know that the new kg dash is 100 times of kg. So I just write 100 here. I hope everyone is following me.
Into
Then I need to convert, yes, meter dash
10 meters.
into meters. Well done, my dear friends. So this will be multiplied. So on the numerator it is multiplied. It would be multiplied by 10. The yellow one, don't worry. So now in the numerator I have kg and I have meter dash and I have meter. Now I look at the denominator, my dear friends. Denominator I have second dash squared. Second dash has to be converted into
1 by
seconds.
10 whole square.
So 1 by 10. Well done, my dear friend. 1 by 10 whole square. And in the denominator I get second square. I hope everyone understands what I'm saying here.
Yes, sir.
Then I look here on the blue thing and I look here on the blue thing. This blue thing that I've got here is nothing but your old force. So I got a relation between the old force, my dear friend, and the new force, and the relation is pretty simple. It's a simple calculation. And what is the result of this simple calculation? My F dash becomes 100 into 10, which is 1000, divided by 100, 1 by 100. So 1 by 100 goes here. So I have 1, 2, 3, 4, 5, 10 raised to the power 5. I think so, if I am not wrong, times of F. Everyone got this answer, beta?
Yes, sir.
New F dash is 10 raised to the power 5 times of F. Can I have raised hands from everyone in the class, online, offline as well?
Yes, sir.
We have understood this. Online, offline classes understood this. What about the online class? Shilata, Kartik, Mani, Anjali, GNB, do we understand this? Can I have raised hands from everyone? I hope you know how to raise your hands in the chat. Any symbol, raise your hand, thumbs up, whatever. It will do. That will make you understand. That will make me understand that you have got this. Kartik, have understood this. What about the others? Do we understand this? Yes, well done. Okay, everyone is following. Remember, this is an online class, but this is more effective than an offline one because I'm watching each and every one. I can interact with each and every one of you in ways which are far better than probably in a offline class. Now, can I give you one question from the previous years?
Okay,
Okay,
sir.
sir. Okay, so let us see if you can solve this question. This is from one of the previous year paper of JEE. Oops. So here comes the question. This I think is question number 3. And here it comes on your screen and I wait for your results. Remember, this question has been taken from a JEE paper and it can be a multiple option correct type. That means you can have more than one options correct. Do we understand this? So you'll have to check probably all the options. Remember, and I always say this to my students, particularly for JEE, that beta, the most difficult questions in the JEE, and obviously I'm talking about JEE Advanced, those questions are multiple option correct because they only give you +4 if all the options are correct. But as you can see in this year, they can give you -2 if any one option is wrong. And therefore, those are the most difficult questions in the JEE. Here comes one of those questions. Questions are only difficult in your head. If you really understand the process, they are all simple. And remember, whenever you see a question, the first thought that must come to your mind, your head, your brain is that this question is simple and that you can solve this. If the first thought that comes to your mind is that this question is difficult, well, you have lost the battle, my dear friend. Remember, every question is simple and it can be solved. Because it is in the paper, it can be solved in 2 minutes. Otherwise, it will not be there. So this is a question for you. I'll give you 2 minutes. You'll have to check all the options probably because this is a question taken from multiple option wala thing. I give you 2 minutes to solve it.
Only D
Only
is
D is
correct.
correct. Only
D is
D is
correct.
correct. Only D is correct, and you get -2, my dear friend.
चलो देखते हैं.
Try it again. Don't worry. The only reason we are doing problems in the class is because we want to make sure that we don't do mistakes in the examination hall. Whatever mistakes you have to do it now in the class and not in the examination hall. And I keep on telling this to all my friends. JEE is not clear in the examination hall. You don't clear JEE in the examination hall. No one can clear JEE in the examination hall. If no one is prepared, if I'm not prepared, probably I'm not prepared. If I go and sit in the JEE, I will not be able to clear it. No, JEE cannot be cleared in the examination hall. It is cleared in your preparation. It is cleared in the class when you do a problem and you understand it. That is where JEE is cleared. In the examination hall, what you do is just replicate what you have done in the class. If you don't do it in the class, you cannot clear JEE. 2 minutes for you to solve this question.
Sir, B and D, sir.
So
Sir, B and
D
D are
D is definitely correct. B is correct. I'm not sure about D. Why you are getting D correct? 1 minute more you have. Shall I do it? I hope everyone is trying the question. Yes, who is talking? Yes, ready. Tell me. B. Yeah, you don't have to. I mean, you can just type if you want to just type the option. But sometimes, if you're not sitting in a place where you have good network, I may not be able to hear you. B is the only option that is correct, my dear friends here. No other option is correct. Only B is correct. How are we going to do this? Remember, the new unit of length is 100 meters. So meter has become 100 times meter, new meter. New seconds has become 100 times of original seconds, green one. And new kg has become 1 by 10 times the original kg. Let us first check option number 1. Let us first check option number A, the new unit of velocity. Let me write the new, original unit of velocity. It is meter per second. The new unit of velocity will be meter dash per second dash. I will just substitute the value of meter dash. Meter dash is 100 meters. Second dash is 100 seconds. And I have this same as meter per second, which is same as V. That means the new V and the original V are same, and therefore this option is definitely wrong. Everyone got this? Yes or no? Can I have raised hands from everyone that we understand this?
Yes, sir.
This was option A, which was wrong. Let me move on to option B in green. Let me just. Okay. Let me move on to the second option, which is B, and I am now checking the unit of force, the new unit of force. Let me first write the original unit of force. Original unit of force is kg meter per second square. My new unit of force will be kg dash meter dash divided by second dash ka square. What I need to do now is substitute the values here. Let me just do it here. I just need to substitute the values here. Kg dash is 1 by 10 times of kg multiplied by meter dash is 100 times of meter divided by second dash is 100 times seconds, so 100 ka square, and then I have the original unit of kg meter per second square. I can write it as F. If I solve this, I will have 10 divided by 10,000. 10 divided by 10,000. I think I'm going to get 1 by 1,000, and therefore this option is correct. Yes or no? I will get from here F dash is F divided by 1,000. Option B is correct. Can I have raised hands from everyone that we understand this? Raise hands from everyone that we understand this. Simple calculations. Online students, I hope you are there in the class. Shilata, Anjali, Jalaj, Manikant. Can you raise your hands and let me know that you have understood this? Online class, offline class. Okay. Now, since we can check all this, and I know that all of these are wrong, option D is what many students told me is correct. So let us now check option number D. And in option number D, we are supposed to check the new unit of pressure. So let me check this one out, and I will leave option C for you to check out. Option number D, the original unit of pressure is force per unit area. So this is kg divided by meter second square. The new unit of pressure will be pressure dash, that will be equal to kg dash divided by meter dash second dash ka squared. Now what I do is I'll just substitute this. Instead of kg dash, I will write kg, which is 1 by 10 divided by, instead of meter dash, I will write 100 times of meter. In place of second dash, I will write 100 times of second dash ka square, and then I will be left with kg divided by meter into second square. That is my original pressure. So my original pressure has become 1 by 10 divided by 100 divided by 100 square. So 10 raised to the power minus 7. I will get the answer as 10 raised to the power of minus 7 if I am correct. Times of P. Option D says that it is 1000 times. This is definitely wrong, and therefore this option is wrong. Similarly, you can check this option will also come as wrong. The only correct option is option B. Do we understand this? Can I have raise hands from everyone that we understand this? And we'll be able to solve any question if it comes on this category. I'm waiting for your responses. Anyone having doubt? Any doubt? Please raise your doubt. If you don't have your doubt, please raise your hands. Whatever way you can, whatever symbol, whatever gesture, that will help me in understanding that we are good with this question. Can I have raised hands from everyone? In the offline class, in the online class, everyone. Great. You can raise your hands like this or like a clap or whatever. That makes me understand that my word is getting across to you and that you are in the same class and not watching YouTube when you should be studying. Okay, so one last question for everyone to give me the correct answer. Is everyone ready? This is the question. If you can do this question, the last question, remember, whenever we are doing physics with me, if you can do the last question, that means you can do all the questions that has come before it, because probably the last question will have all the elements of the previous questions. So even if you can do one question and the last one, that means you have understood the entire topic. It's as simple as that. That is how I frame my question. That is how I ask my question. Easy, 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 tough, 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 more tough, toughest. So if you solve the last one, you solve the previous one as well. So this comes the question, and if you can solve this, we can move ahead to the next topic. So the question looks like this. Suppose we employ a system in which the unit of mass is 100 kgs. Original unit is 1 kg. I know. I hope you know that. The unit of length becomes 1 times kilometer, 1 kilometer, and the unit of time becomes 100 seconds. We call the unit of energy in this new system as E log, which is the original unit joule written in reverse order. What is the correct relation? Again, you can take this as a multiple choice correct question. If you can understand it, looking at the option, you can see that it cannot, more than one option cannot be correct. So this is a single option correct question. Can you tell me which is the correct answer? What is the relation between the new unit, E log, and the old, our unit, the joules? And I will give you a minute to do this. Let me know if you get an answer. A, B, C, D. 4 options are there. And what I can see, all 4 cannot be correct. Even 2 cannot be correct. Only 1 can be correct. Correct. Reddy has given me an answer. Option A. Well done, Reddy. Option A is the correct answer. 1 eloch is 10 raised to the power 4 joules. Well done. We're on the right track, Karthik. What about the others? Online class, offline class. Have I lost all of you? Are you there in the class following the question? Shilata, Manikant, Manikanta or Manikant, Anjali, Jalach, my offline students, are you there? I already have an answer. I'll give you 1 more minute. I want all of you to solve this question on your own. That will give me confidence that we are on the right track. 1 more minute. Offline class, do we have an answer? No one? So, how do we go about this? The original unit of energy. Energy is the unit of energy is half mv square kinetic energy, potential energy, or it is force multiplied by distance. Whatever way you look at it, the original unit is kg meter square per second square, which you can also call as joules. The new unit is E dash, so that will become kg dash m dash squared divided by s dash ka squared. Now what you got to do is just put the values. New kg, which is kg dash, is 100 times of the original kg. So I just write it here, 100 times. New meter dash is 1 kilometer, so 10 raised to the power 3 meters. So just remember that. So multiplied by 10 raised to the power 3 squared, the pink one. This is the yellow one. Don't make a mistake. That is why I'm coloring them, highlighting them, whatever you call it. The new second S dash is 100 times of second, my dear friend. That is in the division part. So I divide it by 100 squared, the blue one. And then I will have kg meter square per second square. That is nothing but my original E, original energy, joule. This is a simple question. 100 multiplied by 10 raised to the power 6, that is 10 raised to the power 8, divided by 10 raised to the power of 4. So my new E dash becomes 10 raised to the power 4 times of the original E, or my new unit of energy E log becomes 10 raised to the power 4 times of my original unit joule. Do we understand this? That is how we solve this. Can I have raised hands from everyone that we understand this? Online class, offline class. Do we understand this? Offline class. Can you hear me better?
Yes,
Online.
sir.
Do we understand this better?
Yes, sir.
What about the online people? Anjali, Jalaj, Manikant, Shilata. Do we understand this? Raise hands. Please let me know. Yeah? Okay, great. So that finishes this use of dimension analysis. In this use of dimension analysis, what we have seen is that we can convert from one system, one unit to other unit using dimensional analysis. That is the first use. That takes me to the next use of dimensional analysis. But before going on to the next use, let us read and understand some important points about dimensional analysis or dimensional equations that we will have to employ in the questions that are going to come after this. So let me write some important points and I hope everyone will note them down. Important points. The first one of this important point is known as principle of The first one is known as principle of homogeneity. Now, don't get confused by the term principle of homogeneity of dimensional equation. The term may look very complex, but it means pretty damn simple. And it simply says that in dimension analysis or in any question, in any equation in physics, now there is a difference between an equation in physics and an equation in maths. In equation in math, what you have is you have numbers on the left hand side and you have numbers on the right hand side, because in maths you do not get physical quantities that much. Basically numbers on this side and numbers on the other side. But in physics, when you have a physics ka equation, instead of just being numbers, in some cases there would be numbers. In most of the cases, you will have physical quantities on left hand side and similarly physical quantities on the right hand side. That is how the equation of a physics is different from equation in maths. Now, when you have a physics ka equation, what will you have? You will have physical quantities on left hand side and physical quantities on right hand side. Now, if that is the case, whatever physical quantity is on the left hand side, the same physical quantity must be there on the right hand side, because else we cannot equate. For example, you cannot equate mass with length because they are different quantities. You cannot equate force with, let us say, acceleration or momentum or mass because they are different quantities. When you're writing a dimensional equation, when you're writing an equation in physics, whatever physical quantity we have on the left hand side, same physical quantity we should have on the right hand side. Since the physical quantity is same, then I can write dimensions. And that's an important factor. Dimensions on left hand side of the equation will be equal to dimension on the right side of the equation. Remember here, what we are concerned about is only the dimensions. We are not looking to find the values of those physical quantities. How much is force? We are not concerned. We are only concerned with the part that dimension on the left hand side and dimension on the right hand side should be same. Otherwise, that equation is wrong. So this is known as the principle of homogeneity, and you should remember this principle because every question in dimensional analysis that you are going to do, you are going to use this principle of homogeneity. So this is the entire chapter in one point. Whatever we do in dimensional analysis in units and dimension, this chapter will be done on this principle of homogeneity. Dimension on left hand side and dimension on right hand side are equal. That is point number one. Did you understand this? Can I have some reason that we understand this?
Got it, sir.
Okay. Principle of homogeneity. Let us move ahead. Now, in some cases, most of the cases, you will be encountering equations like this. You will have one physical quantity added with another physical quantity, or one physical quantity subtracted from other physical quantity. Now, we must understand that if I have mass as one quantity and if I have length as the other quantity, I cannot subtract mass with length, or I cannot add mass with length. I can only add mass with mass, length with length, force with force. That means I can write this in this way: only physical quantities that are same. Remember, only those physical quantities that are same, since they are same and they have same dimensions, can be added or subtracted. I can only add or subtract those physical quantities that are same. In any equation, in any problem, if you are adding or subtracting two physical quantities, they must be same. You can only add mass with mass, time with time, length with length. You cannot add mass with length. Now, how are we going to use this? So you can see it with an example. How are we going to use this? For example, if I have F is equal to A plus BT plus CT square. Suppose I have an equation like this. Now remember, whenever we are studying in physics, we are studying the theory behind it. And what we got to do is apply this theory in solving problem. And that is where we probably miss how to apply this theory in the problem. And that is why I will always give you an example of how to apply this, whatever we have learned in an examination hall. Now here we are going to use both the principles, number 1 and number 2, at the same time. How are we going to use? So what I see on the left hand side, I see a physical quantity which is in blue. Yes or no? No. Whenever we see something written as F, and here I am going to tell you, this F actually stands for force. This F actually stands for force. So let us say that we have force on the left hand side of the equation. We have force. Now on the right hand side, we have not one but two, not two but three physical quantities. Now can you tell me, if I color this physical quantity A with green, what type of physical quantity would be A? The entire physical quantity A. What type of physical quantity would be A? Remember, on the left hand side, we have force, and on the right hand side, we have three physical quantities. What would be A? Yes, Karthik, A would also be force. Why would A be force? Why would A be force? Because on the left hand side, we have force, and on the right hand side, force can only be added or subtracted or equal to force. Force cannot be equal to mass. So if on the left hand side I have force, on the right hand side I should also have force. So the quantity A will be force. Do we understand this?
Yes, sir.
Now look at this entire quantity in pink. This entire quantity in pink is B into T. T could be something. T would be time probably. My question is, what would be this entire quantity BT equal to? What type of quantity would be B into T? It would be a physical quantity. What would be it? Remember, we are not talking about the value of this quantity. We're only concerned with what quantity is this and what is the dimension. Yes, Reddy, you are correct. This BT also must be force, because force can be added with force. Force can only be equated with force. If A is force, B has to be force. I mean, B into T has to be force, right? Remember. Then I have this third quantity, C into T square. What type of quantity this would be? And it's a
That could
no-brainer.
also be force.
That would also be force. Now you will say, sir, what is wrong here? On the left hand side, I have one force, but on the right hand side, I have three forces. Well, remember what we are understanding here. We will not say it like this, sir. This is F and this is F plus F plus F. Sir, on the right hand side, I have three F. On the left hand side, I have one F. Remember, we are not talking about the value that F is equal to 3F. No, we're just talking about the dimensions and the units of these physical quantities. Do we understand this? All of these physical quantities, whether it is A or B into T or C into T square, would be equal to F. We are not calculating the values of what these forces are. We are only stating that all of these must be forces. So here what we have used principle number one, principle of homogeneity, left hand side force, right hand side force, and principle number two or point number two, only those quantities can be added or subtracted which are same. Do we understand this? Point number one and point number two.
Yes, sir.
I hope everyone is noting it down. Have you noted it down?
Yes, sir.
Then that takes us to the next point, point number three. We have talked about addition and subtraction. What about multiplication and division? Can we multiply and divide only same physical quantities? Or we can also multiply and divide different physical quantities? What about multiplication and division? Addition and subtraction can only be performed on similar physical quantities. What about multiplication and division? Can it be done with same quantities, or can it be done with different quantities, or can it be done with all quantities?
Both, sir.
Both, sir. Yes. Physical quantities, whether they are same
Or different, they could be
or different, yes, my dear friends, can be multiplied, or divided, giving new derived quantities. So when you multiply or divide two physical quantities, you will get a new derived physical quantity, which is derived from the quantities that you have multiplied. Example: length into length. You have multiplied two lengths, you get area. Yes or no?
Yes, sir.
I multiply length into length into length. You say, sir, why is calling them length? Why not calling them length, breadth, and height? Doesn't matter. The dimensions are same. Length into length into length becomes volume. So I multiply length three times, I get new quantity volume. Force is equal to mass multiplied by acceleration. Do we understand all this? So when I multiply mass with acceleration, two different quantities, I get force. P, which is momentum. Have you heard momentum? Is mass multiplied by velocity.
Velocity.
So I take two different physical quantities, I multiply, and I end up with a third quantity which is entirely different from mass as well as velocity, because it is a new physical quantity. That is point number three. I hope everyone is noting it down. Yes or no? No, yes. Yes or no? No, yes.
Yes, sir.
Next point. If two same physical quantities are divided, we call it a ratio. Remember what I have written here. Two quantities which are same and are divided, we get something known as a ratio, which has which has no unit or dimension, because it is a pure number. Do we understand this? Yes or no? No,
Yes,
yes.
sir. Yes, sir.
Yes, sir. Yes, sir. Example, sir. Density of substance divided by density of water. Have you heard this? is known as specific gravity or relative density. Heard about this? And the specific gravity or relative density is just a number. It has got no unit. It has got no dimension. So whenever we are multiplying two same physical quantities, yes, Reddy, refractive index is also one of them. We have discussed this in the previous class. Refractive index is also one of them. You divide two same physical quantities, you will get a ratio. A ratio is a number. It does not have unit, does not have dimension, but there is one exception here. Like two exceptions here. We have discussed that exceptions as well. Can you tell me what is the exception to this rule? There are two exceptions to this rule. When you divide two same physical quantities, but you don't get a ratio, you get a ratio sort of thing, but it has a unit. The exception to this rule is plane angles and solid angles. Plane angles and solid angles are also ratios because we get them by dividing the same quantities. But these two things, plane angles and solid angles, what is peculiar about them? Plane angles and solid angles. What is peculiar about them? I told you in the previous class. They have no dimension, but they have a unit.
Unit.
So these are the only two exceptions to this rule. Otherwise, whenever you divide two same physical quantities, you will call it a ratio. I hope I am not making things complicated and you are able to understand it. Yes or no? Yes or no? No or yes?
Yes, sir.
Okay. The next one. Point number 5. I hope everyone has noted this down. Point number 5. Some quantities are numbers always. And these quantities are going to appear in your physics wala class in physics, and those quantities are always numbers. Example, log of, let us say, x square plus 2x. Now if you have this quantity ever coming, this is a mathematical expression. Now if I talk about this entire yellow thing, this entire yellow thing is just a number. Do we understand this? Log of anything, you find out the log of anything, that would be a number. Yes or no?
Yes, sir.
But one more thing you have to understand. If you look at this bracket, what is there inside this bracket is also a number only. That means what I mean to say is x square plus 2x is a number. It has no unit and it has no dimension. Do we understand this? So x squared plus 2x is also a number. It does not have any unit, does not have any dimension. Log of this entire thing is also a number. It does not have any unit, does not have any dimension. Do we understand this? Yes or no? No or yes?
Yes, sir.
This is example number A. Example number B, e raised to the power x. If I talk about e raised to the power x, or let me make it more complicated, let me write it as e raised to the power x square plus x. If I write it like this. Now if I talk about this entire quantity, e raised to the power something, this entire quantity is a
Is a
number.
number.
Also, whatever is coming in this bracket is also a,
It's a number.
because you cannot raise e raised to the power of 3 meters. You can only raise e raised to the power 3. Do we understand this?
Yes, sir.
Similarly, last point, point C, sine of something, omega t plus x. Let us say this. Sine of omega t plus x, or cos of omega t plus x, or tan of omega t plus x. This entire thing is,
Is a number.
this entire thing is a number. But here, just be careful that this entire thing is not a number. This is a angle.
Angle.
This is an angle. An angle has no dimension. So dimension wise it is 0, but it
It
has a
has a unit.
unit. So remember that. That is the only difference. So we have seen some important points about units and dimensions. We have seen one of the use. In the next class, we will be going ahead and seeing more uses of dimension analysis, and then we will be applying them to the problems that we are going to get, and we will solve even the most complicated problem that has ever come in the JEE, including the problem that came last year. So I mean this year, not last year. In JEE Main as well as JEE NEET, I have all those problems and we will solve them one by one. Don't worry about that. I will end today's class here. I hope everyone is making notes. Yes or no?
Yes, sir.
Every point that we write in this class may come as a question in your exam. And remember, one correct question can get you in and out of a dream IIT that you are aspiring for. And I want all of you to get whatever you aspire for and whatever you deserve. So I will end this class here and I'll see you in the next class. Take care. God bless you. If you have any doubt, please
Thank
ask.
you, sir.
Bye bye.
Nice.